Hello, welcome back to Sushi Live Nodding. In this episode, I'm going to share with you one way we can create this kind of like square spiral using node setup in SphereChop. And there are actually many ways to create this kind of a square spiral. And if you ever study Python programming or other programming, and you will encounter one of these like a turtle module where you can kind of like a draw like a lines using like a turtle object. And this is actually very interesting, and if you're really into math, pattern, and algorithm, very nice way to understand like how the algorithm will work. And if you are using this kind of algorithm, it's kind of like a slightly different way of thinking if you are kind of doing it using nodes. So this is like a one way you can kind of like a cheat an algorithm, because there is no right or wrong way to do it. As long you are like you're gonna end up with the same result anyway. So in this case, I will show you how I end up with something like this. So basically, before I end up with this, it looks like very complicated, but actually it's more like a study of pattern. So what I did, I start with a line in SphereChop. I'm just drawing a line from this point to that point, just 2 points, a simple line. So 2 point simple lines. And if we are going to draw like a square spiral, the next line should be from this point up to this point, right? So that I'm drawing the second line here, the orange color one. The second line should be similar from the first line, except that the second one should be like placed at that point, like a 1, 0 at that coordinate, and the line itself is being rotated 90 degrees in 0, 0, 1 axis. So just move. If you have like a match or stick line, you just move this red line into this point and then rotate it 90 degrees. So that's the second line. And then the next one, you just let's say you move this line and then you draw this line that's like kind of like 2 units longer. And then you're gonna draw the next one, which is similar to previous one, just slightly rotate it again and then place at that point, and then the next one, and then continue, and so on and so on. So that's 5 kind of like a 5 steps to draw this spiral. And then the lines itself is gonna be separate lines for now anyhow. So this is one way you can approach it. So what I did here is kind of, I look at this 5 samples of 5 steps, and then there's some kind of similarity, except that the number kind of making this kind of pattern in terms of this step. So I'm looking at the step. So it's I'm writing it down. Step. This is one unit, and the next one is going to be 2 units. So that's for the step value. So 2 units, and then the next one is 3 units. So we can see there's a pattern already. The pattern itself is quite simple. And then with the X and Y coordinates, I also write down the pattern from the very beginning, which is like 0, 0. The second one at 1, 0, 0, 0, 1, 0, 1, 1, and then continue, and so on and so on. And with the rotations, it's also kind of grow from 0, and then the next line is like 90 degrees, and the next line is 180, and so on and so on. So that's the 4 patterns that we can pass into this this kind of setup line and transformations. So based on these information, I will now hide all these 5 steps. We can sort of replicate the pattern. So this part slightly complicated, but not really. The first pattern, so 1 1 2 2 3 3 4 4 is like you can use integer division. This is very, very common. So you start with some kind of range of number, 0 1 2 3 4. In this case, I'm kind of shifting it slightly. So I'm changing the start value, and using integer division, we're gonna get this 1 1 2 2 3 3 4 4. So we get this pattern already. So one problem solved. So that's for the steps. The next one, the X and the Y have similar pattern. If you look at this, okay, it's very, very similar, 0 0. So with the X and Y, actually I actually started using the integer divisions and using modulo. So we need these 2 pattern and kind of combine the 2, because the first one is like this, just like 0 0 1 1 1 1 2 2 2 2 like that, using integer divisions, while the other one slightly more interesting. I'm using integer divisions. If you look at this pattern, 0 0 1 1 2 2 3 3, and then if I'm using modulo on top of that, we're gonna have a different pattern. So it's becoming 0 0 1 1 0 0 1 1. So we get that 0 0 and 1 1, and if we are using map range, we can turn that into minus 1 minus 1 1 1 minus 1 minus 1. So we have that pattern, and multiplying this pattern and this pattern, we're gonna get this 0 0 1 1 minus 1 minus 1 2, and so we get this pattern for X and Y basically. And then using some kind of slicing and shifting the number, we get the pattern basically. And for the rotation, it's very, very simple. Just use a range of number and then multiply it. Actually, we just need to increase the step. So we get this 0 90 pattern, and so on and so on. Okay, so that's actually pretty much it. Once you have the pattern going on, you can increase this number. It's gonna, you can have this spiral square. And this spiral square, the spiral square, actually, I did this mesh join and remove double. But if you want the stick figure to be like separate, you can have it like this. So if this is the originally how it looks, and if we separate it, it's like each one of them is separate. So maybe that's what you want. You can combine using mesh join, combine but still separate. But if you remove doubles, you're gonna get the spiral square that's actually a single object. If I back it up, see it's a proper spiral, and we can turn it into skin modifier, and we get that. Okay, so that's pretty much it. It's just actually one way you can approach something like this using SphereChalk. You can of course use some kind of math formula that actually give you the coordinate XY right away. That will work as well. And there are plenty of other algorithm, like the turtle way is slightly different. It's using some kind of loop because the turtle objects actually have some kind of directions. You can you can definitely actually have some kind of turtle kind of algorithm to work inside SpectreChalk or maybe animation nodes, but this is like one way you can do it using SpectreChalk, just because I don't know, just because the way it works. You can definitely simplify this, but I like it as it is. If you want to study the pattern like this, if you ever encounter pattern, step-by-step pattern to generate points for your mesh, then you can always you can create anything basically. Well, at least that's the idea. Sometimes it's not so simple. It took me just a while just to get into this point. But anyhow, that's how you can approach this kind of situations. Hopefully this is useful for you. Let me know what you think, and I'll see you next time. Thank you. Bye.